Hello everyone. This time we're going to look at the EOQ with lead time. We're going to look at four cases here. We start with uncertain demand and uncertain lead time. As usual, we can assume that you know the holding cost, ordering cost, purchase price are given, and we also have the distribution of the demand and the distribution of the lead time. Here, our demand has a mean of 100 units per day, standard deviation of 20 units per day, and the lead time is 10 days, and standard deviation of lead time is 1 day. Okay, and you want a service level of 95%. So, given these parameters, we can calculate the mean lead time, which is just simply 10 times 100. Okay, and then the standard deviation of lead time will be given by this formula here. Okay, so and from there we can get the safety stock. Okay, and if we know the safety stock, then we can determine the reorder point. Okay, so it's gonna be the the mean demand times the mean lead time plus the safety stock times the Z, right? Okay, so Z is a function of this service level. Okay, with this we can calculate everything. Okay, we can calculate the EOQ, um, inventory, and all the way to the annual cost. Okay, the holding cost, the setup cost, and all the way to the annual cost, right? So as you can see here, with a certain demand and a certain lead time, our reorder point will be 1194 units. So meaning once we hit 1194 units, we have to pick up the phone and start ordering a new batch of goods. Now let's look at the second case here. We have uncertain demand, meaning um, the standard deviation for demand is non-zero, and you have certain lead time, meaning the standard deviation of lead time is zero. Okay, meaning you are sure that the lead time will be 10 days exactly. Okay, here in this case, you're 10 days plus or minus 1 day. Okay, here you're sure it's gonna be exactly 10 days. So the consequence is that the reorder point will be lower. Okay, safety stock will be lower, then the reorder point is lower, and because the reorder point is lower and the safety stock is lower, the average inventory will be lower, and therefore the holding cost will be lower, right? Okay, because holding cost is a function of average inventory. So the average inventory will be lower, holding cost will be lower, and the total cost will also be lower. As you can see here, the ordering cost and the purchase cost will be the same. Okay. Now let's look at the case where you have certain demand and certain lead time. Certain demand meaning you have zero standard deviation in the demand, in the daily demand, and zero standard deviation in the lead time. Okay, so in this case here, your reorder point, okay, you do not need any safety stock. Your reorder point is just simply D times L, right? So, you know, the mean daily demand times the lead time, so it's gonna be 1,000 units. Okay, so your average inventory will be 2,500, and your total cost will be 2.5 million roughly. Now we have this case here where you have an instantaneous receipt. Okay, so this is a special case of this one. This is a case where the lead time is zero. Okay, um, meaning if the lead time is zero, like once you pick up the order, it's already there right away. So that's why it's called instantaneous receipt. Okay, instantaneous receipt of the order. So in this case here, your reorder point will be zero. Okay, you don't need to. You can order when you have nothing, because once you pick up the phone, it's gonna be there right away, like a genie giving it to you right away. Okay, so you can again calculate the EOQ, and assuming you actually ordered the EOQ units, then the total cost will be this $2.5 million. So these are the different cases with EOQ with uncertainty in demand and lead time. Okay, so next time we'll talk about other topics like linear programming, news vendor model, and so on. Thank you.